So in grade 11, we learned the reciprocal function. Again, this is the same thing as a y. You're flipping the y values. So 1 comma, or x comma 1 over y. You're flipping the y value. Okay, so the 5 negative 8 turns into 5 comma negative 1/8. Negative 8 turned into a negative 1/8. Do you notice how I don't change positive, negative, anything like that? If it's negative, it's still negative. Okay, negative 6 comma, how do you change 1/2? What does it become? If you reciprocate that value? 2. And then 3 comma 1 becomes 3 comma. What happens to the value 1 if you flip it around? 1 over 1 becomes 1 over 1. Five comma 0 becomes 5 comma. This is a... Doesn't work. Undefined. Yeah, you remembered. Undefined. Okay, so 0 over 1, if you reciprocate it, it becomes 1 over 0. What happens to divide by 0? Can't do it, but I want to know the value, so that value is called undefined. Okay, how do you graph undefined? Big fancy word. Asymptote. You're going to be graphing asymptote. Do you remember that word from last year? Asymptote. All right. So we did these exact questions I'm going to do. We did them in grade 11. Okay, when I graph reciprocals, I always have a 4-part process. So I look for heights of 0. So if a height of 0 would turn into a asymptote. If you ever have a height of 0, the new height flips asymptote. If you ever have a height of 1 or negative 1, it's going to stay. What happens if your height is far away from 0? Example 50. It would turn into close to 0. So if you're really high, away from 0, you go close to 0. And what happens if you are close to 0? What do you get if you flip that value? You're going to have to go away from 0. So an example, if numbers, something close to 0, would be something around 1 over 100 is close to 0. So now it's going to shoot away from 0. Okay. I have to introduce you to another fancy math word. So asymptote, that's already one thing in your brain today as a fancy word. Here's another one. You might run into this. Invariant point. Break down that word. What does vary mean? Change. What does invariant mean? No change. So what do you think a point is going to do if it's invariant? Is a point that stays invariant. It's going to not change. Okay, so here we go. Grade 11 questions that I gave you. Step 1. Where do you see heights of 0? I see them here and here. These coordinates are at a height of 0. So what are the new heights? Undefined. Do you remember the look of this now? Undefined heights here. 6, 0. So 6, 0 becomes 6, undefined. That's what I did there. Does that make sense? The point 6, 0 became the coordinate 6, undefined. Okay, I'm going to go to invariant next. Which coordinates will never move on this when I flip their value? Right here and right here. Why are they not changing? Because the height of them was a height of 1. Now I'm going to fill in the pattern stuff. So the pattern would be far from 0, close to 0, close to 0, far from 0. So I'm going to take this coordinate, which is the farthest away, 0, 4. It's now going to be the closest. So what's the new coordinate? 0, 4 becomes 0, 1/4. So do you notice how it was the highest? Now it's going to be the lowest. Okay, so if it's the lowest, we're going to have to travel up to that, up to that. That's that section. Okay, I want you to think like this. Where my pen is, what's going on with the heights of this pen starting in this section? From here to here on the graph, what's happening? We're getting smaller, 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 right? We're getting lower, lower, lower. So what should we do instead if we reciprocate that? We should get bigger, 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 bigger. What should your graph do when it gets to this asymptote stuff? What should my graph be doing? Getting closer and closer and closer. Should I touch that line? No. Should I curve away from it? No. So people who are at an asymptote and do something like that, I have to take you off a point on your exam. If you kind of curve away from it, that's a deduction on your exam. Because you have to go asymptotes, you always approach them, you never cross them, you never touch them. That's always, no matter where you are. Okay, grade 11 question. One more. This was also on your grade 11 test. Okay, starting, where do I see heights of 0? At -4, I would have an asymptote. And at 2, I would have an asymptote. Okay? What if my question didn't ask me to graph it? What if my question just said, what are the equations of the asymptotes? What would this equation be of this asymptote? Do you know how to write an up-down line? How do you write an up-down line, a vertical line? X equals 2. How do you write a flat line? Y equals. Here your X equals, remember that from grade 10? And then X equals -4. So you might have just random questions like that. Instead of graphing, I might just say, where's the asymptote? Okay, you have 3 invariant points on this graph. Can you find 3 invariant points. So that might be another question. How many invariant points do you see? So there's my 3 invariant points. I went to a height of 1, and I went to a height of -1 and figured those ones out. Okay, I'm going to do this triangle section. Let's grab the lowest point here, the farthest away. 0, -3. Where are you going to move it? I think there's maybe a hint on your page. 0, comma, -1/3. This, if this was the bottom point, now it's considered the top point. So we're going to have to go through there, and then what do? Shoot away. Because the original section is close to 0, so we're heading away. Okay, and the last section here was just an arrow, so let's go to where my pen is. All of these heights from 0 to 1, can we say all of these heights are close to 0? They're small heights. So what are my new heights going to do? They're going to head up, get bigger, because these ones were small, so I need to get bigger. From 1 and beyond, what are your heights doing? From here and beyond, the heights are shooting away from 0. So your new heights should shoot closer to 0. Uh-oh, something has happened. Anybody remember what happened from grade 11? There was one additional thing now that's been created. Something to do with this right here, this pattern. It also has an asymptote. Yep. Okay. Anytime a graph ever has a behavior where it's getting closer, 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 closer to something and never touching it, that's an asymptote. So now we need another asymptote here. The reason is this line will always keep getting smaller, 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 no touching, no crossing. Okay? If I also asked you the name of that asymptote as an equation, what would it be? Y equals 0. Okay? Why didn't my first graph have that involved? There's no shooting away arrow. There's no arrow that goes on forever away. So as soon as you see an arrow that goes away, 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 that is the cause of it. Away, away, away becomes closer, closer, closer.